Okay, we are going to put all of our rules together. So, okay, so today's problems are basically we're going to put all of our different rules together. There's going to be multiple steps, and so some things to keep in mind. Coefficients. Treat them just like normal. If your coefficient, the number that's out front, is negative, that is totally okay. The problem is when your exponent is negative. So we only care about negative exponents. So an example would be negative 2x to the fifth. The coefficient is what's negative. Totally fine. There's literally nothing to like fix or simplify or change about this. It would only be a problem if the exponent itself was negative. Then the other thing is take each variable one at a time and kind of simplify and deal with each variable one at a time. Don't try and do multiple variables all at once. Okay, first example. In parentheses, 6y squared over 3y. So 6y squared is 6y times 6y, which is 36. 6 times 6 is 36. Y times y is y squared over 3y. Okay, so we're going to simplify our coefficients. 36 in the numerator, 3 in the denominator. 36 divided by 3 cancels, simplifies down to 12. And then y squared over y. Remember when you divide things that have the same base, you're going to subtract the exponents. So this is technically y to the 1 power. So this is 2 minus 1. So it's y, and just one y is left. I like to think of this as 36 and then times y, because there's two y's. Y squared is y times y over 3 times y. So these y's cancel out. So there's no longer a y in your denominator. There's only one y in the numerator. Okay, x squared times y to the negative 1 to the second power. Okay, power to a power, you multiply. X squared to the second power is x to the fourth. Y to the negative 1 times 2, power to a power, you multiply. I'm going to multiply the negative 1 times 2, so it'll be y to the negative second power. Okay, now the only thing I need to change is the fact that this y has a negative exponent. I cannot leave that negative exponent in my final answer. Totally okay that x is raised to the fourth power. That one doesn't need to change. So x to the fourth is going to stay in the numerator. But in order to get rid of this negative exponent, I'm going to send y squared to the denominator because that's going to turn that exponent from negative into a positive. Negative 1m to the fourth over 5mn to the ninth raised to the third power. Okay, so my numerator is totally fine. There's nothing to change. So then I'll have 5 cubed m cubed, because it's just m to the 1. So 1 times 3 is 3, so m cubed. And then n to the ninth raised to the third power, I'm going to multiply those exponents. 9 times 3 is 27. And then the only thing left to deal with is the fact that I have m's in my numerator and m's in my denominator. And so when I'm dividing things that have the same base, I'm going to subtract the exponents. 4 minus 3 is 1. So I'll have negative 1m left in my numerator over 5 cubed is 5 times 5 times 5, which is 125 into the 27th power. You might also just see this as negative m over 125 into the 27th. Either way, it's totally fine. Okay, negative 5z cubed, all of that squared. So I'm going to think of this as negative 5z cubed times negative 5z cubed. I want to see that visually. Over z to the negative 4. We'll deal with that in just a second. Negative 5 times negative 5. Negative times negative is a positive. You're squaring the negative 5. When you square a negative, it becomes positive. So negative 5 times negative 5 is positive 25. Z cubed times z cubed is z to the 6th, which makes sense because what's 3 times 2? 6. When you raise an exponent to another exponent, you're going to multiply. 3 times 2 is 6. All over z to the negative 4. And so now the problem is, we have z to the negative 4 in our denominator, so we're going to need to bring it up to the numerator, so it'll be 25z to the 6th, and then we bring up the z to the 4th into the numerator, and now there's nothing in the denominator anymore. And so now I'm just going to multiply z to the 6th times z to the 4th, multiply same base. I'm going to add the exponents, so it's going to be 25z to the 10th power.